Welcome to the podcast series Inclusive Research and Innovation in Science, Technology, Engineering and Mathematics. Inclusive research and innovation takes place whenever science, technology, engineering and mathematics scholars actively integrate the diversity of human beings in their work. In doing so, they contribute to inclusive processes and results. Yet, how do we get there? My name is Claudia Werker, and I'm an associate professor at Delft University of Technology in the Netherlands. I host this podcast series on IRI in STEM. Guests of this series will be various colleagues from different universities of technology. All of them consider IRI in STEM principles or explore of how to do so. Today, I welcome my colleagues from Graz University of Technology in Austria. Dr. Cornelia Lex, Dr. Mario Hirz and Dr. Corina Klug. They all work on safety and security systems for automobiles. Welcome, all of you. It is a pleasure to discuss with you today how research on safety and security systems for automobiles currently look like and whether and how it has to change to produce truly inclusive results. So let me start with Corina Klug. Would you please be so kind to tell us about your professional background and your research and innovation activities?
My name is Corina Klug. I'm leading the research group on accident and injury prevention here at the Vehicle Safety Institute at Graz University of Technology. And my research focuses on trauma biomechanics, which actually means that we try to understand the mechanical behavior of humans in dynamic events, such as a car crash. And this is important to understand then the injury mechanisms, to be able to predict the injury risks, and then finally prevent the injuries.
And that means that in contrast to your colleagues, you are really working on solutions for situations when the crash actually occurs. That is in contrast to Connie, who actually works on situations where the crash might still be, I understood, prohibited. So could you perhaps briefly introduce yourself?
Yes, I'm happy to. I'm Cornelia Lex, working at the Institute of Automotive Engineering, and I deal with driver assistance systems and vehicle dynamics controls. And especially driver assistance systems, they try to interact with the driver to prevent a situation. So when it's critical and we still see a chance to avoid an accident.
Right. And then we have Mario, who actually works on situations where you have regular driving. Perhaps you could also tell us how diversity of human beings play a role in your research.
Yeah, for sure. So my name is Mario Hirz. I'm associate professor here at the Institute of Automotive Engineering at Graz University of Technology. And my research is covering different aspects of sustainable and future mobility. And in the course of this research, we also investigate new vehicle concepts, new technologies for future mobility. And here, of course, ergonomics plays an important role, seating comfort, seating safety. And yeah, I can tell some more in the next minutes about our investigations.
Yeah, perhaps it's a good idea if you start with a situation where actually nothing has happened yet. Could you tell us a bit more about how ergonomics plays a role in this safety?
Yeah, for sure. So we have different vehicle types, vehicle architectures, from small cars to sports cars, SUVs, sedans. And it's very important that people of different size, of different gender, feel well, feel comfortable in the cars, can enter the cars in a proper way, so via the door and the door flange, and then at the end have a good seating position. And for developing these situations and proper solutions, we use human models, human body models for female and male gender and of different sizes. So just to give you an idea, so such a human body model is used, for example, in computer-aided design. So these are virtual models which represent the size of the human, then the extension of the legs and the arms, and some other aspects as the view of the eyes, the view areas, and movement capabilities. And in general, there is the so-called 50% model that represents the average size of a male or a female model. Just to give you an idea, for the European male model, I think the 50% is 179 centimeters large. And this is the average size. And corresponding also the female model has an average size. But this 50%, the average model, is not sufficient to develop a good ergonomics interior of a car. So therefore, we also use a smaller model, the so-called 5% model, where 95% of all persons are larger than this 5% model. And this is used for the lower area of adjustment of the seat for the smaller people. And of course, we use the 95% model, where 95% of all humans are smaller than this model, where we use it for the, let's say, upper extension of the seat adjustment of the ergonomics. And this is the challenge, to develop proper comfort, proper safety, proper seat position, reachability of the switches in the car, of the pedals, of the steering wheel, and to prepare corresponding adjustment.
Very interesting. I understood from what you were saying that you are mainly working with virtual models. Do you also sometimes have people around of different sizes, shapes, weights, and so on?
Yeah, that's an important point. So of course, these virtual models just can represent an average behavior. And of course, we do studies with people of different proportions of the legs, of the body, and of different weight. So to have more specific information about the people's behavior. What is very important is that the age plays a role. So younger people are more flexible in their movabilities, older people are less flexible. And of course, modern car development has to consider this aspect too.
Does that also mean that you would work with colleagues from other disciplines to sort of reflect or work on these differences in younger and older people, or do you investigate that all from an engineering perspective?
No, we of course have joint projects. For example, some years ago we had a project with the Medical University in Graz, where we received very valuable information. In that case, it was about accident scenarios and implants that we developed. But of course, we have cooperation with the experts in those areas.
Right. Perhaps I turn now to Connie, who is actually still more on the regular kind of driving, but in more challenging situations. Could you give us a kind of insight what you are actually doing and how you work with diversity of human beings and possibly also interdisciplinarily?
Yeah, we are working or developing functions for advanced driver assistance systems and automated driving. And there are different levels of automatization. So the lowest level is where we just warn the driver that there is a critical situation, but the driver still has to react and give inputs to the vehicle. So steering, braking, accelerating is all still part of the driver's job in this scenario. With increasing automation, some of these steps go over to the vehicle. For example, system with low degree of automation would be the automated cruise control that many vehicles already have. So for example, on the highway, I could set the vehicle in a way that it keeps distance to other vehicles. When there is no vehicle ahead, it could have a certain maximum speed it should be going. So then I, as a driver, am not responsible for adapting the longitudinal control. The vehicle is doing this, but I still have to monitor the road, have to adapt the steering wheel in order to stay in the lane. And we've seen from accident research and others that people are very different on how they react to warnings, what is more effective for them, how, this whole interaction with the system, it has to be clear at all times who is responsible for what. I, as the driver, have to know what the system is doing, in order to be objectively safe, but also subjectively safe. Because if I don't feel safe with the system, I will not use it at all. So as long as I have a choice to turn it off, I would not use it if I don't feel comfortable.
Right. You were saying that the different persons also react very differently to challenges in this situation, that they have automized driving systems. Could you say how they react differently? Has that something to do with age or gender or the like?
There are a lot of studies, so there are mainly two ways of dealing with this problem. You can look into situations where accidents already occurred and look into what were the main causes for this. For example, not adapting the speed in this situation. And there we see that we have a very high influence of age. So too high speed is very typical for young drivers, and it decreases to a high extent with age. Mm-hmm. But we also see gender effects, for example, that this effect is much stronger with young men than with young women. Mm-hmm. Okay. And then there are other cases, like if you could, so accidents that occur in crossings where people mistake the rules who would be allowed to go first. This increases with age and is also slightly higher for women than for men overall, all ages investigated.
Very interesting. Do you work together with colleagues from other disciplines like behavioral economists or people like that who actually can investigate how behavior differs?
We work a lot with psychologists. We also have a driving simulator where we do test with participants, because this whole spectrum we want to test there in a safe environment with a high number of people with different characteristics. So a lot of psychologists, also experts in medicine on how we can measure like stress in people in an objective way.
This means that you usually work with human subjects to test all that, and that you can most likely use less virtual models than your colleague. Is that correct?
Yeah, as engineers, we would love to only use models, but especially for humans, since the standard deviation in the behavior is so high, modeling the human behavior is really, really challenging. And as Mario already mentioned, even if we have a good model, we need to validate it, and we have to see if what people are doing there is also happening in real life, and really shows the whole spectrum of human behavior. So it's important to do both.
Okay, thank you very much. Very interesting. And now I move on to Corina, who is actually in charge of the crash test dummies, and they are very often used as an example where engineering solutions are not well designed for women, but it's not as strong as it is often said in the press, where you can read that crash test dummies are not female at all, but I let Corina explain how it really is.
Thank you. Yeah. I would like to start maybe with explaining a bit on what the injury risk actually depends on. And here we have different groups of factors. So on the one hand side, it's of course the crash severity, so the situation I am in, because if you have a higher speed, of course you have a higher injury risk than if you are involved in a crash with a lower speed. But it's also the vehicle you're in, so that's the vehicle crashworthiness, as we often call it, which means how well is my vehicle equipped with different safety systems, so how good is the airbag, the seat, but also how big is the mass of the vehicle I'm actually in, because mass differences also play a big role in the outcome of a crash. Then the next thing is the intrinsic factor, so who is in the car. And here we again see a difference depending on the age, on the gender, on the body height and weight. So the whole body shape is affecting the injury risk. But then it can be also medical preconditions. And in line with the body shape, and here relate to what Mario has said before, people also sit differently in the car. So there is also an interaction then with the distance that I have, for example, to the airbag, or with the belt fit that I have, because people sit differently depending on their weight and height, and also their sitting height, for example. So it's not just the total body height, it's also some differences that we can see here in between. So we can see it's quite a lot of factors, and they're also interacting with each other, and that's what we currently see in the field. And then different accident studies come to different conclusions, also depending on the filter criteria that are applied and the parameters that are considered. But we can see that those things have an effect as such. And when we then look what we're currently testing in regulatory crash tests, that's of course much more simplified, because there we have to define some standard conditions so that we have a reproducible and repeatable assessment. And what is currently used there are mainly two types of crash test dummies. For frontal impact, we use a 5th and a 50th percentile dummy, and the 5th is a 5th percentile female. So this one has body mass of 49 kilograms, and for the 50th, that's a 50 percentile male. So that's again what Mario also mentioned before, the 78 kilograms that is used there as a replication of the human body. But in reality, we can have a lot of different shapes, of course. And so what we're trying to do now is to get more variance and robustness then into the assessments also. And one nice way to do that is, of course, then here the simulation. So we work with finite element human body models. So those are finite element models of the whole body. So where we have all the bones, so the whole skeleton included, then also the soft tissue, and we have the joints as we have in the human. And we can morph those models into different body shapes and assess how well the protection is still working with those different body shapes, and investigate the robustness of the safety system.
Right. I guess that you also work together with other scholars from other disciplines. Could you name who would be relevant for your area of research?
Yeah, of course, this is a very challenging part, or a very challenging task. So we need a lot of different disciplines. We work closely together, of course, with medical professionals. So with doctors who see the injuries then finally in the hospital, and therefore know the problems best. But then, of course, we also need a lot of medical knowledge to develop such human body models correctly. So there we also work together with institutes for anatomy, for example, and those who characterize then also the material properties. We also work, on the other hand, of course, together with the vehicle engineers, so those who design the cars in the end, because we don't have unlimited degrees of freedom. So again, the person also has to be comfortable in the car. So we could do a lot of things that might make the human more safer, but are not really accepted then by those who are in the car. So it's also then the behavioral science plays a role, because if we one example is the 3-point safety belt. So it's really a compromise of something that keeps you safe, but is also accepted by the clients. If we would restrain the person more, it would be safer, but then no one would use it, and then we don't have any benefit.
Right. That is very interesting. Perhaps I would first like to ask you as a follow-up. I understood that you three also work often together or sometimes together. What would be these kinds of collaborations about?
Could maybe give one example of what Connie has said before, when we have active safety systems that can help to prevent a crash. We often have the question, okay, but what are the remaining crashes? And if we get better and better active safety systems, how does this change our in-crash scenarios then in the future?
Mm-hmm. Mario, I think you also wanted to react.
Sure. Another aspect is the complete vehicle architecture, the vehicle styling, the integration of the vehicle components in the so-called packaging process. So this is more or less the hardware configuration. And of course, here we need a very close integration of the processes and very close collaboration to develop, on the one hand, the vehicle styling, vehicle powertrain integration, systems integration, and on the other hand, the most important part, the integration of the people, the driver and the passengers. And yeah, here we have a very close cooperation, of course.
I understood that basically if the persons using the cars would be willing to do more or would be restricted more in their comfort, it might be safer. But from the research side, would you say that you also would need something in terms of regulations or funding or whatever comes to mind to pursue the kind of research you're doing?
Yeah, I can maybe say here some words around the safety, because to me it often feels now when I read research calls and action plans that the safety has lost a bit on weight or priority on some of the agendas.
Mm-hmm.
I think is a pity, because we still globally have 1.3 million road fatalities yearly.
Wow.
So we're not there, although
Mm-hmm.
we all feel safer in our cars than we felt some years ago. And we are, of course, safer. We're still not on the end of the road, especially globally seen. And
Mm-hmm.
also when we think of Europe, I think, so when we often talk about Vision Zero, we of course have to reduce the road fatalities, because everyone who dies on our roads, it's too much. But we also have to work on long-term consequences, and we should also not forget about this, because it can be that you have an injury with a very low injury severity when the injury severity is weighted according to the risk to die from an injury. One example is, for example, the whiplash-associated disorders.
Mm-hmm.
But people or shoulder injuries is another example that's often mentioned, or that we often see in our research, where, yeah, you will not die from this injury, but you can have long-term consequences, and you can have many years of pain, and you might not be able to work for quite a long time. And that's also something we have to work on.
Right. Connie, could you perhaps tell us a bit about the more or less self-driving cars? What, as a driver, would I have to consider, or how would I have to behave to be as safe as possible, given what I have as a kind of car?
An ideal scenario, I would know the system I'm using very well, know its limitations, know which situations it can handle in a very good way, know where I can rely on the system. So there are several studies that have shown that when people learn these new systems, that there are mainly three types of interactions. So there are ones that are very pessimistic from the start and don't trust the system at all and use it as little as possible. Mm-hmm. And in this situation, of course, the system cannot support this type of driver. Then there are others that are very, very optimistic and have too much trust into the system and think the system can do everything. And of course, this can also be quite dangerous. Mm-hmm. So the best way would be a person in the middle who starts to test the system in not dangerous situations, just to find out what are the limitations of this exact system, and then can use it in real driving scenario the way it is intended.
Are there some kind of training so that you can get used to the system, or is that something that people have to do on their own?
There are a lot of discussions if there should be a training for these kind of systems. So if you, for example, compare driving on the road or getting a driver's license to, for example, when you learn how to fly, that this whole schooling system is very, very different. So as a somebody flying a plane, you have to do much more training, have to learn all the systems. If you have a new type of vehicle, you have to learn the techniques there. But again, for a vehicle, this is not something that would be acceptable for the users. So we have to see that we have enough safety measures, but people are still using these systems. So especially for the low automation systems, we want to make them as intuitive as possible. But of course, people are different and it will not be as intuitive for everybody in the same way.
Mario, if I ask you of how we could be particularly comfortable in a car as a person, for example, as a woman or as a very long person, what would we have to do? How would we have to sit also to be as safe as possible, of course?
Mm-hmm. Yeah, in general, the seat should be adjusted to be comfortable, to be to ensure that all the elements you need for driving are good reachable. So there are these standard boundary conditions to do not have the back seat rest too flat, so more upright position, and so on. I think this is more or less known. Here I see that some car manufacturers, out of different reasons, do not provide the full adjustment possibilities that could be provided. Length of the seat, but also adjustment of the steering wheel, for example. So here might be some potential for improvements.
Mm-hmm. Why don't they do that?
Out of cost reasons, mainly out of cost reasons, in some cars out of packaging or placement reasons.
Right.
Another aspect I would like to mention here is the new challenges that we have. And this is related to your former question. So autonomous driving cars, here we see some types of new architectures, some new vehicle types that are going to be developed, so-called fully autonomous people mover. These cars do not have steering wheel or pedals anymore, so they will be driven fully autonomously. And this opens, of course, totally new challenges, but new possibilities. People are sitting there more like in a train or in a tramway, so in opposite, also with the backside to the driving direction. And this, of course, gives new challenges in terms of safety and comfort. In addition, in these people movers, the people are not so related to the actual driving situation as it is in a traditional car. So they can consume entertaining or work or perhaps even sleep. And this also leads to totally different behavior of the body and of the passengers in case of accidents. So here I see much work in the next years for improvement, for understanding at first how people react or the bodies react in case of safety relevant situations. And there is much to do.
Yeah, that sounds really like a challenge. Corina, could you also tell me, because I'm really curious, as a woman, of course, you said there are a lot of aspects, a lot of things that contribute to being safe or not safe beyond gender. But as a woman, how could I make sure that I'm safe, that I'm unlikely to die in an accident or have an injury that costs me months to recover from? Is there a golden tip you have?
I think, some of the things have been already said. So I think it's good not to sit too far or too close to the airbag, so to have a good compromised position here. And we often see this especially on the passenger side, because on the driver side you have the restriction that you want to reach the steering wheel and you want to reach the pedals. But on the passenger side, we can often see people sitting very much backwards and very reclined, and that's of course not favorable then in terms of a crash. Also, the seat belt fit. So really try to have the belt positioned on your pelvic bone, and then have it on the shoulder belt really going centrally on your body. So I often see people taking the upper part of the shoulder belt and putting that behind their body, and of course it doesn't protect anymore. So these are like low-hanging fruits that you could do. And then also not because now it's getting colder, don't use a super thick winter jacket in the car, because that also then limits the functionality of the seatbelt. And then I think one important thing and one important factor is that when you select your car, that you really have a look how the safety performance of this car is. So we have a big consumer information organization here in Europe that's called Euro NCAP. So for whatever car you pick, you can go on the website and check the safety equipment of that vehicle. And I think that's important, that this is really a factor that is considered, because several of the cars that are popular for females don't have a super good safety equipment. And therefore, I think this is really something you should look into. And it doesn't mean that it's only the super expensive cars, but it's worth to check it out beforehand.
Right. So the recommendations are more general, really, for men and women, because I think everything you said works for both.
Yeah.
But to have a look that you do not pick a car that is as such not particularly safe, that is, of course, a good recommendation. Thank you very much. I have asked you tons of questions, and perhaps you think now, well, I would have liked to contribute this or that, and she didn't really ask that. So please feel free to fill the gap if you feel that this was the case now.
I think the message that I wanted to get through is that people are different, humans are different. We have heard that now in many terms. So it's different body shapes. So we have different behaviors, and if we can get assessments of the vehicles and designs of the vehicles closer to the real world and then the real usage, and therefore consider the diversity of the humans in a better way, I think we can design better cars for everyone. I think we have made some big progress towards that over the last years, but there are still some more important steps to do. So Mario has mentioned before that for ergonomics, you use the 50% female and the 50% male, and then a fifth and the 95th. In safety, there has not been a 50% female now for many, many years. So we have been part of one EU project where we have developed the 50% finite element human body model, which really represents the average female, and that has now happened for the first time. Right. And now we try to work further on making then even more different females and more different male shapes, so that we can evaluate the safety for those as well.
Well, that sounds very promising. Connie, do you want to add something?
In my field, I really saw a difference over time on how these problems were addressed, because in the past, everybody thought that a good strategy of a driver assistance system would work for everybody. But we saw that people interact so differently with these systems, and also their subjective safety depends on different things, that this got much more important in research. And it was very nice today to be a part of this talk and also to see what my colleagues are working in this field, and that topics like age, gender, diversity are getting much more focus in this field.
I just want to thank you for having us here today in this podcast. It was really a pleasure, and I'm looking forward to hear the result.
Great. Thank you once again for contributing to our podcast series on inclusive research and innovation in science, technology, engineering, and mathematics.